Prince George's County Public Schools presents HSA Prep for Algebra and Data Analysis. All problems will come from the public release problem sets, which are accessible to students through the Maryland State website at www.mdk12.org. Once again, that's www.mdk12.org. HSA Prep, because now it counts.
Hey everybody, this is Mr. Owens here with your HSA Prep lesson for today. We're going to work on a few problems dealing with Goal 1. So let's take a look at what Goal 1 actually states. Core Learning Goal number 1 deals with functions in algebra. The student will demonstrate the ability to investigate, interpret, and communicate solutions to mathematical and real-world problems using patterns, functions, and algebra. So a lot of these things that we're going to deal with in Goal 1 are probably some things that you've seen so far in your Algebra 1 course. Okay? So let's take a look at our first problem for today. So the first thing we're going to take a look at indicator 114. And indicator 114 deals with what we call properties of nonlinear functions. So we deal with things such as domain, range, and continuity. So let's take a look at our first problem for today. Our first problem says, look at the function that is graphed below. The question asks, what is the range of this function? So the key word here is range. What is the range of this function? So the first thing we have to know is we have to know the difference between our domain and our range. Now when we talk about domain, domain refers to our x values, okay? And our range refers to our y values. So when we're talking about domain and range, domain refers to the x and range refers to our y values. So let's take a look at our problem again. So when we talk about the range of the function, we want to focus on the y-axis, because the y-axis deals with the range and the x-axis deals with the domain. But the question says that we're trying to find the range of the function. So if we're trying to find the range of the function, we want to see what's our lowest point on the graph. So our lowest y value on the graph would be right about here. And that point is y equals -2. Our highest y value would be y equals 4. So our lowest value is y equals -2. Our highest y value is y is 4. So our y value, or our range, is going to be, so y is going to be greater than or equal to -2, but less than or equal to 4. And that would be answer choice D. So the biggest thing we have to remember in this problem is the difference between domain and range, everybody. So remember, domain deals with the x-axis, and range, we're looking for the y-axis. Okay? So keep that in mind. Now let's take a look at our next problem. Still dealing with our indicator 114, now we want to talk about continuity. So the problem says, look at the function that is graphed below. It says, for what value of x is this function not continuous? That's a key word. The key word is not. So not continuous. So then the question is, well, what does it mean for something to be continuous? In other words, when we talk about continuity, we're talking about something that doesn't have any breaks in it. So when we talk about something that's not continuous, that means it must have some form of break or kind of like a gap. So let's take a look at our problem and see if we can find any places where there are breaks or gaps in our graph. So if we take a look at our graph, if we start from left to right, let's start here. If we go along, doing good, going up, whoop, going up, whoop, coming back down, and hold up, there's a problem. Here we have a break. And remember, we don't want to have any breaks because that goes against the definition of something being continuous. Something is continuous if there are no breaks or gaps. So since there's a break right here, the question is, what value of x does that break occur at? And if we take a look at our graph, I can see that our break occurs when x is 5. So our break in the graph occurs when x is 5, so that means the value of x where the function is not continuous, that would be answer choice D, because that's the point where our graph has a break. Okay? So when we talk about continuity, remember, continuity means there are no breaks. So everything is kind of free-flowing. It's continuous. But anytime you see a break, that's a place where the function is not continuous. Okay? Now, let's take a look at our next indicator. Our next indicator is indicator 121, which deals with determining the equation of a line, solving a linear equation, or describing the solutions using numbers, symbols, or graphs. Now, this is something that you've probably seen maybe in your chapter 2 in your Algebra 1 course or unit 2 where you deal with solving equations. And you also may see it in your unit when you talk about things dealing with linear functions, okay? Talking about slope, y-intercept, things of that nature. So let's take a look at our first problem. Our first problem says, look at the function that is graphed below. The question says, which of these equations represents this function? So we want to know which equation represents the graph that we have displayed. So if you notice, all of these equations, each of the equations is written in what we like to call y-intercept or slope-intercept form. So slope-intercept form. Slope-intercept form. And then my question is, well, what is slope-intercept form? Slope-intercept form is y equals mx plus b. Now, before we actually deal with the problem, let's talk about what those things mean. First of all, we have our m value. And our m, if you recall, our m equals our slope. So anytime we see m, we're talking about slope. And then we talk about, well, what is slope? When we deal with slope, we're thinking about a rise over a run. Okay, so when we talk about slope, we're talking about our rise over run, or we're talking about our rate of change. Now let's take a look at our b. Our b value is our y-intercept. And the y-intercept is the place where the graph crosses the y-axis. So now that we know what our m and our b represent, let's see if we can find those in our problem. So first, let's try to identify our b, or our y-intercept. So remember, we just said that our y-intercept is the place where the graph crosses the y-axis. So let's take a look and see where our graph crosses the y-axis. So if I take a look at my graph here, I can see that if we start from left to right and we go all the way up, we're going up, we're going up, we're rising, we're rising, we're rising. Oop, hold on. Here's our point where our graph crosses our y-axis, because remember, our y-axis is here. So our graph crosses our y-axis at y equals 4. So at y equals 4, so this will be the point x is 0, y is 4. That's the point where our graph crosses the y-axis. Now, so that means we know that our b value is going to be 4. So let me write that up here. We know that b is going to be equal to 4. Now, good test-taking strategy. One of the things you can do is you can eliminate some answers that you know do not match the graph before you actually go and find your final solution. So one of the things that we know already is that b is going to be equal to 4. So let's look and see if we can eliminate some equations that don't have a b that's equal to 4. So let's take a look. Now, if I look at b and c, if I look at b and c, I notice that both of them have a b value of 2. Because here, my b would be 2, and here the b would be minus 2. So b has a b value of 2, c has a b value of minus 2. So we can eliminate those. And remember, why can we eliminate those again? Because we said that b is going to be equal to 4. Now, let's take a look. So now we're between a and d. Now, if we look at a, we can see that we have 1/2 x minus 4. But remember, we said that b is going to be a positive 4. So we actually can eliminate a as well. So our answer is going to be D. Y equals 2x plus 4. So everybody, that's a good strategy to use when you're taking the test. Sometimes you can eliminate some of the answers that you know are incorrect before you actually work toward finding the correct solution. In this case, we were able to eliminate 3 answer choices. Think about that, everybody. We were able to get rid of 3 answer choices just because we knew what B represented. So that one little piece of information helped us to actually get the correct answer. Okay, let's move on to our next problem. Okay, our next problem says a rental car company has 2 rental plans. Plan A charges $49 per day. Plan B charges $25 per day plus 10 cents per mile. How many miles must Terry drive in one day for plan A to cost the same as plan B? Okay, so the first thing we're going to need to do in this case is we're going to need to set up some type of equation. Now, everybody, when we deal with problems like these, I want you to remember our cues for students, okay? So one of the first things you want to do is you want to analyze the problem. So you actually want to read the problem. Make sure you read the problem, everybody. Make sure you read. Read the problem very carefully. And then once you read the problem, think about what is the question actually asking you to do. So let's take a look at our problem again, and let's try to analyze it this time. So it says a rental car company has two rental plans. Plan A charges $49 per day. Plan B charges $25 per day plus 10 cents per mile. How many miles must Terry drive in one day for plan A to cost the same as plan B? So the question is asking us, how many miles must Terry drive in one day for plan A to cost the same as plan B? So in other words, we want to know when are plan A and plan B going to be equal. Okay? So now, in order to figure out when plan A and plan B are going to be equal, we're probably going to have to set up some form of equation. And that leads me to the second thing that we talk about in our cues for students, which deals with representation. So let's represent our equation. So first thing we need to do, if we're dealing with an equation, we need to define a variable. In this case, our variable, let's say we want to know how many miles. So let's use M to represent the number of miles. So M equals the number of miles. Okay? Now, the next thing we need to do is we need to write an equation that represents this situation. So M is going to be equal to the number of miles. So we have two plans. So first of all, we have plan A. Plan A says $49 per day. So for plan A, we're going to represent that using our 49. Now, there's a reason why we're not going to make a variable for per day. The reason being is because in the problem they ask us how many miles must Terry drive in one day. So we already assume that the number of days is going to be 1. But let's write that down. So D equals the number of days. Number of days. Okay. Now plan B, according to the problem, says plan B charges $25 per day plus 10 cents per mile. Okay? So $25 per day plus 10 cents per mile. So now let's set up our equation. So remember, it says how many miles must Terry drive in one day for plan A to cost the same as plan B. So that means that we're trying to figure out at what point are both plans going to be equal. So let's take a look. So plan A is $49 per day. So we said D is going to represent our days, equals $25 per day plus 10 cents per mile. And we said miles are going to be M. Now, we also said that we know that the number of days is going to be 1 because the question says how many miles will it take for them to be equal if Terry only rents the car for 1 day. So we already know that D is going to be 1. So let's substitute that. So if we substitute a 1 for D, it will look something like this. 25 times 1 plus 10/100 M. Okay? Now, I'm going to go extend this just a little bit so we can continue the problem. Okay, so if we do 49 times 1, we get 49. And then 25 times 1 is 25. Okay, now we want to solve an equation. So our goal is to get the variable by itself. In this case, our variable is M. So we want to isolate our variable. So we're going to isolate our variable by first subtracting 25 to the other side of the equation. So let's go ahead and do that now. And the reason we're subtracting 25 is because we want to perform what we call the inverse operation. So if this is a positive 25, we want to subtract 25 from both sides. Okay? So now we have 25 minus 25. That's going to cancel. That gives us 0. And now we have 49 minus 25. So 9 minus 5 is 4. And 4 minus 2 is 2. So 24 equals 10/100ths m. Okay? Next thing we want to do is we want to divide both sides by 10/100ths. And the reason we're dividing is because here we have multiplication. And keep in mind we're doing the inverse operation, so the inverse of multiplication is to divide. Okay, so let's go to our handy dandy calculator to figure out what that solution would be. So let's take a look. So we have, first let's turn it on. We have 24 divided by 10/100ths equals, so 240. So this means that Terry would have to drive 240 miles. So Terry must drive 240 miles for plan A and plan B to cost the same amount. So Terry's going to have to do a little driving. She's probably going to have to go to the mall a couple times. She may have 240 miles. She might have to go out to Ocean City, in order for both plans to cost the same amount. Now, that would be what we call our explanation. Now, let's verify that what we did is correct. Now, let's see, how can we do that? We can do that by substituting our value for m back into our original equation. So let's take a look at that. So our initial equation is 49 equals 25 plus 10/100ths m. And remember we said that m is equal to 240. So let's substitute that into our equation. So 49 equals 25 plus 10/100ths times, we're substituting 240. So 240. Okay, close parentheses. Woo. Okay, so we have 49 equals 25 plus 10/100ths times 240. A quick way of doing that is taking 240. Decimal point is here. You move the decimal point one place to the left. And so 25 plus 24. And if we do it on our calculator, we would get the same result. And 25 plus 24 gives us 49. So since both sides of the equation are equal to each other, we know that we have the correct answer. And that would be our check. All right, everybody. I hope you enjoyed this session, helping to prepare you for the high school assessment in algebra data analysis. I wish you all the best on the test. Remember, we're striving for 412 and beyond. I'm Mr. Owens, and I'll see you later.